Okay, so what we have here is a 3-bit weighted resistor digital to analog converter. Okay, so if you notice that we are using here an inverting operational amplifier. Now, we have here three switches represented by S2, S1, and S sub 0. These are actually your inputs, and we want to determine the analog output of your weighted resistor digital to analog converter. So the digital value S2, S1, and S sub 0 actually these are the data coming from your DSP or digital signal processing. Okay, so we know that from the analog to digital converter, it will produce a digital signal and it will be processed by your DSP. Okay, so a refined output, digital output is being processed by your DSP and will transmit this data into your digital to analog converter. Now, this one here is the general formula for your 3 bits weighted resistor digital to analog converter. VO is equal to minus VR RF over R times 2 to the 2 S2 plus 2 to the 1 S1 plus 2 to the 0 S sub 0. Okay? So the question here is how do we arrive or how do we derive this particular formula? No? Okay. So we will start with determining the value of your IS. Okay? IS is actually the total current, no, flowing towards your operational amplifier. What is IS? IS is actually equal to I2, I1, and I sub 0. Now, when is IS equal to I2, I1, and I sub 0? For example, if the value of your the output of your digital signal processing is 111. Okay? So the value is 111. That is the signal, the digital signal coming from your DSP. So this value here, 111, will be inputted into your switches S2, S1, and S sub 0. So in other words, if S2 is 1, that means that this S2 here will be connected to your VR. Okay? And if S1 is also 1, that means that your S1 here will be connected to your VR. Okay? And so as with SO equal to 1, that means that the switch is connected to your VR. So with this particular condition, there will be current flowing across your resistor R sub 2, no? Since we have the supply here, VR. So that VR is connected now to your R sub 2. And then your VR here is also connected to your S1 and then S sub 0. So we can say that the total current IS will be equal to the current flowing in this particular circuit, which is I sub 2 plus I sub 1 plus I sub 0. So that will be the current flowing on your circuit, no? Particularly your IS. Okay? Now, we know that I sub 2 will be equal to, using Ohm's law, VR over R sub 2. Okay? That is the value of your I sub 2. Now, your S sub 1, since it is closed, that means that I sub 1 will be equal to VR over R sub 1. And since S sub 0 is also closed, that means that I sub 0 will be equal to VR over R sub 0. Okay? Now, let's try to, since this is weighted resistor, the value of your R, for example, or your R sub 2 is equal to R over 4. And then your R sub 1 is equivalent to R over 2, and R sub 0 is equivalent to R. Okay? So these are, if you notice that we have here R sub 0, that is R over 1, for example. So you have 1, 2, 4. So it is increasing. The value is increasing, or the value here, which is under your R, or which is being a number, or a value which divides the value of R, is increasing. Alright? So if you have R sub 3, that means that the value of that is with R over 8. And so on. So 1, 2, 4, 8. That will be the designation or the values of your R here. Alright. So, if this is R over 4, we can also say that R sub 2 will be equal to R over 2 to the 2, because 2 to the 2 is 4. Okay? And then R sub 1 can be equal to R over 2 to the 1, because 2 to the 1 is 2, right? And then we can also say that R sub 0 will be equal to R over 2 to the 0, because 2 to the 0 is equivalent to 1. Okay? Now let us substitute these values here in our equation here, this one. Okay? So IS therefore is equal to R over 2 to the 2 plus R1, or I sub 1, which is equivalent to what? No, this is not R but VR. VR over R 2 to the 2. Alright? Can you follow? Since VR, I sub 2 is this value here, so we substitute this value here in I sub 2. So you have I is equal to VR over R. Since R sub 2 is R over 2 to the 2, so you have R over 2 to the 2 plus I sub 1, which is VR over R1. So you have VR over R1. What is R1? R over 2 to the 1 plus I sub 0. That is VR over, what is RO? R over 2 to the 0. That is your IS. So, if we will simplify, or let us move the, since VR here are common, so let us factor out VR. So you have VR will be equal to what? VR over R is common. Alright? So VR over R is common. So you will have what? 2 to the 2, that is 1 over 2 to the 2, that is, pwede na ito isaka na siya, no? So you have 2 to the 2 plus 2 to the 1 plus 2 to the 0. Okay? Now, let us assume that you have switches here, S1, S2, S1, and S sub 0. Let us place it here, S2, S1, and S sub 0. So if the condition of your S, for example, is 1, 1, 1, that means that S2 here is 1, alright? So you have 1 times 2 to the 2 is 4, plus 1 times 2 to the 1 is 2, plus 1 times 2 to the 0 is still 1. That will be the corresponding value, no? So the condition of your switch, or the value of your switch, depends on the condition of your inputs. Right? So, that is now our IS. And we know that IS here, okay, is equivalent to IF. Right? So, we can say that IS is equal to minus IF. Why minus? Because IF is connected to the negative part of your operational amplifier. So that means that IS is equal to minus IF. And what is IF? IF is equal to V out, VO, or V out over RF. Okay? So we can also say that IS, therefore, is equivalent to minus V out over RF. So we have two equations of your IS. This one here and this one here. Okay? So we equate the two IS. So what we will be having is minus VO or V out over RF is equivalent to this one here. VR over R times 2 to the 2 S2 plus 2 to the 1 S1 plus 2 to the 0 SO. Okay? So that will be your representation of IS. We equate the two equations of IS. So if we will try to solve for V out or VO will now be equal to minus, okay, cross multiply. So you have VR RF over R times 2 to the 2 S2 plus 2 to the 1 S1 plus 2 to the 0 SO. Okay? So that is equivalent to, or that is the general formula for a 3-bit weighted resistor. Alright? Now, assuming that we have VR equal to 5 volts, then let's say RF is equal to, let's say, 5K. And R is also equal to 5K. Okay? Now, what will be V sub 0 equal to? So all you have to do is to substitute these values here in our general formula. So what will be VO? VO will be equal to VR, that is minus 5 volts, times RF, which is 5K, okay, over R, which is also 5K, multiplied to, since you have 2 to the 2, since S2 is 1, so you have times 1, plus 2 to the 1 times S1 is also 1. Alright? So S2 is 1 and S1 is also 1. You times 1 plus 2 to the 0 times SO is also 1. Okay? So what will be your VO? VO will be equal to minus, cancel this one. So you have 5 volts times 2 to the 2 is 4 times 1 is 4 plus 2 to the 1 is 2 times 1 is 2 plus 2 to the 0 is 1 plus 1 times 1 is 1. Alright? So minus VO therefore, or VO therefore, is equivalent to 4 plus 2 is 6 plus 1 is 7. 7 times 5 is 35 or minus 35 volts. That will be your VO. No? That is only one value of your analog signal with digital equivalent to 111. So if the value of your DSP, the output of your DSP is 111, that will be translated here in your digital to analog converter as a switch is closed. This one here, closed. And then this one here becomes your output. VO will be equal to minus 35 volts. Okay? So that means that 111 in digital form using this weighted resistor, 3-bit weighted resistor, the output will be equivalent to minus 35 volts. Now, this VO here is actually an absolute value. No? So in other words, this can be positive 35 volts. No? Okay? So absolute value ang iyong voltage output. So this is the maximum value of your output voltage. So if your input, for example, S2, S1, S sub 0, coming from your DSP is 101, okay? So that means that in your formula, which is this one here, right? The general formula that we derived, that means that since S sub 2, S sub 1 is 0, that means that this value here will be 0. So what is left is this value here and this value. Alright? So that is 2 to the 2 is 4, plus 1 is 5. 5 times 5 is 25. That will be your voltage output. Okay? So if the voltage value is 0, if you have switches here, the signal coming from your DSP is 0, 0, 0. That means that all of the switches here are connected to the ground. Right? So if it is connected to the ground, no current can flow across your operational amplifier. So this is 0, 0, 0. 0 multiplied to any value will be equal to 0. So your voltage output will be also equal to 0 volts.